Welcome everyone in this video tutorial of mixed design of concrete, that is example of mixed design of M20 concrete by using Indian standard method of mixed design. Now let's start with this example. We are designing M20 concrete, and as I have explained about the steps, design steps of IS method in the previous video. If you are not watching the steps followed, please go and watch the previous video of design of M20 by IS methods. Now let's start. First of all, target mean strength is calculated. For M20, Ft equals to FCK plus 1.65 S equal to 20 plus 1.65 into S. S is standard deviation is 4 equals to 26.6. You can just calculate in your paper and pen by using calculator. I have explaining here. Now this S value is in table number 8. Yes, 456 2000 clause 9.2.4.2. For M20 and 25, the deviation is 4, M10, M15 3.5, and so on. And after calculating this value, we take the water cement ratio from the table number 5 plus number 6.1.2. The maximum water cement for the M20 is 0.55. So we have considering the 0.47, that is less than 0.55. So for 20 size of aggregate. And number 3, calculation of the water content. Water content is again taken from the table number 2 clause 4.2. Maximum water content per cubic meter of concrete for nominal maximum size of aggregate. For size of aggregate 20 the maximum water content is 186 186 in kg here. 186. Table number 2, maximum water content per cubic meter of concrete. For 1 meter cube concrete, we are taking the 1 meter cube total volume of concrete equal to 1 meter cube. So we have calculated the water cement ratio 0.47, water content 186. Now cement content equals to 0. We are cement equals to water content divided by water cement ratio. W by C equals to 0.47. C equals to W by 0.47. W equals to 186. 186 divided by 0.47 equals to 395.75 kg. Now, after this, we are calculating the volume of aggregates, that is total volume of aggregates here. In next step, from table 3, volume of coarse aggregate per unit volume of total aggregate, that is given in zone number. For zone 2 and zone 1, that is these zones aggregates, the aggregates found in these two zones are used for the concreting. So we are considering the zone 2 and the size of aggregate is 20. So volume of coarse aggregate per unit volume, per unit total volume of aggregate, that is total volume means sand plus coarse aggregate. So volume of coarse aggregate per unit volume of the volume of coarse aggregate per unit volume of the total aggregate equals to 0.62 for 20 from table number 3 clause number 4.4. Zone second 20 side 0.62. So volume of fine aggregate equals to 1 minus 0.62 equals to 0.38. Total aggregate volume is considered for unity. Unity means 1. So for unit volume of aggregate, that is total aggregate, the volume of coarse aggregate 0.62 per meter cube of total aggregate, and volume of fine aggregate is 0.38 per meter cube of total aggregate. Now total volume 1 meter cube is considered, that is volume of cement, sand, aggregate and water. So here the volume of aggregate, sand and aggregate per unit volume of total aggregate is found. For but total volume of aggregate equals to total volume of concrete minus volume of cement and volume of water. So volume of cement and water should be calculated. Volume of cement equals to mass by density. Mass is calculated 395.75 divided by density equals to specific gravity into 1000. 3.15 into 1000 given in question, 0.126 meter cube. And similarly for water, volume of water equals to 186 divided by 1000 equals to 0.186 meter cube. So volume of total aggregate, that is sand plus coarse aggregate, equals to 1 minus 0.126 minus 0.186 equals to 0.688 meter cube. So volume of total aggregate is 0.688 meter cube, but here volume of coarse aggregate equals to 0.62 per meter cube of volume of total aggregate. So directly we are calculating the mass of coarse aggregate equals to volume into density. Volume equals to 0.62 times 0.688 into density equals to 2.7 into 1000. This becomes 1151.7 kg. And similarly for fine aggregate, volume of fine aggregate per unit volume of total aggregate is considered, and mass equals to volume into density. Volume equals to 0.38 into 0.688. Total volume into density equals to specific gravity into density of water, 2.65 into 1000. That is 0.38 into 0.688 into 2.65 into 1000 equals to 692.82 kg. Now we are just arranging this in the ratio cement sand aggregate ratio. Water cement ratio is considered 0.47. Cement content is 395.75 kg and sand is 690.82 kg. Coarse aggregate equals to 1151.7 kg. Now divide the fine aggregate and coarse aggregate by 395.75. We get the fraction, we get the proportions of cement sand aggregate is 1 is to 1.75 is to 2.91. In nominal mix for M20, we are explained that we are saying that for M20, 1 is to 1.5 is to 3. But in our IS mixed design method, the ratios is obtained is 1 is to 1.7 is to 2.91. This is the fraction for 20 mm size coarse aggregate, water cement ratio 0.47 and M20. Now we will be discussing about other design mix, that is ACI method and DOE method, in our next video tutorials. Thank you for watching.